right. All right. So, there's a few things I want to mention for the review here. A couple of these things we've been doing, we just haven't been calling them by the specific name that's referred to on the review. One thing is, in thermodynamics, when two systems are put together, they'll trend toward equilibrium. And that just means, like, you put an ice cube in some hot water, the ice cube will get hotter and the water will get cooler, and eventually they'll all be the same temperature. They'll be at equilibrium rather than one's hot and one's cold. And remember that ice cube's particles are not moving very much. That's what that temperature is. Are you listening back there? All right, I'm making sure you're alive. As that ice cube warms up, it's got more entropy because it's more disorganized now. Got my list of things to talk about. Another thing that we've been talking about, like when that problem on Thermo 1, I think, where the truck had its brakes and its brakes were squeezing them, and the brakes got hot. And it converted the truck's kinetic energy into thermal energy. And then before that kinetic energy was kinetic energy, it was chemical energy in that truck's gas tank, in that gasoline. Potential chemical energy. So energy doesn't, I know we've mentioned this before, energy doesn't get created or destroyed, it just changes forms. And that's the whole focus of thermodynamics. Another thing is, you know, when I talk about entropy, I talked about your room. I asked 2 classes ago, and there were actually 3 of them that had a clean room, they said. And I thought that was very impressive. It is very difficult to keep a clean room. My room is not clean. I mean, this room is pretty clean. My desk is all right. It's all right. It's not awful. You guys want to rate my desk on a scale of 1 to 5? 5 being the most messy. 3 or 2, yeah, that's what I would say. Yeah. Yes, what you got? Oh, 5? Oh, rude. Well, if you clean your room, the only thing that room is going to get is more messy if you leave it alone. Naturally, it will trend toward being more messy. Things are going to just fall, and dustiness, and more messy. Or like, think about if you like build a shack outside, and then you leave it alone. It's eventually going to fall down. It's going to change its potential energy into kinetic energy, and then it will have less energy because all that kinetic energy will transfer into the air around it and the earth vibrating when it falls. And so that's another thing. Systems will trend toward having lower energy and higher entropy. So like that shack is nice and built with its walls here and its roof here. When it falls down, it'll have higher entropy because now it's a big pile of chaos. It's all disorganized. Also, it has lower energy now. It used to have all this potential energy. It's up high, and then it fell down. It transferred all that energy into vibrations and movement of air, maybe some friction, thermal energy, and then that dissipated. So that's an example of that. What's on the board is a triple point. So there's a thing that talks about triple point. One thing about entropy, we just said it increases with temperature because these particles have more organization than these particles. So as you go this way, entropy increases. But entropy also increases with pressure because particles in a container, as you squeeze it more together, yes, they'll usually get hotter because with increased pressure is increased temperature, as we learned in chemistry with Boyle's law, or wait, whichever one of those it is. But even if the temperature doesn't increase, and you just have more particles per volume unit here, less volume, and all the particles are still there, they're just denser. If it's still a gas when you compress it, let's say you're compressing a gas. If it's still a gas when you compress it, those particles they have the same temperature, so they're moving the same amount, but because there's more of them, instead of going point, 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 point inside that container, now they're all real close together, so they're against the walls of the container. And that's part of what makes, can they see that? There's a faucet here, I'm hitting it. It's part of what makes it have higher entropy if there's higher pressure. Even if the temperature doesn't increase, those particles are going crazy in there because they're so dense. Knowing what triple point is isn't critical to answering the question that it says, but I'll show you. Have you guys heard that if you go to a higher elevation, like if you try to boil water in Denver, that it boils more easily?
Yeah.
Doesn't take as long?
Where?
Denver, because it's got a very high elevation because it's in the mountains, or the base of the mountains, but still way up there. That's because, like, let's say, I'm not sure if this is a chart for water or not, but let's say it's for water. So, like, if at a given pressure, if we increase the temperature, water is frozen, so it's ice, and then we increase temperature enough, it melts, and now it's a liquid. And then we increase it more, and it vaporizes. By the way, vaporization is the official name. Boiling and evaporation are types of vaporization. I learned that at trivia one day. I was like, they were like, what's that phase change called? And I was like, it's called boiling. And they're like, no, it's evaporation. And I'm like, I'm going to look it up. And I did, and I was like, we're both wrong. It's vaporization. But they didn't give me the points back. Anyway. Right, you can continue, it vaporizes, and now it's a gas. But if it has lower pressure, you can see it melts a little easier, a little earlier as far as temperature goes, and it boils a lot earlier. You can see this turning into a gas line is it'll boil a lot sooner. And if you get below a certain pressure, it'll go straight from a solid into a gas, and it'll just have steam coming off it. That's what dry ice does. If you've got dry ice is solid carbon dioxide, if you just put that in a normal pressure area, that's what all that steam looking stuff coming off it is. It's sublimating, going straight from a solid to a gas. And by the way, the opposite of sublimation is deposition. That's like if it's cold and you get ice on your windows, like ice crystals, and it's not like it rained on the windows and then it froze, it just went straight from the air right onto the window. Instead of like the dew ending up on the window, it's just ice because it's cold. That's deposition. It went straight from vapor to a solid. The question in the review today refers to triple point, which is that point at which the pressure and the temperature is very specific, and it's such that it can be a solid, a liquid, and a gas at the same time. Or at least very close to that.
What would that even be like?
I don't know. I don't know what that would be like. There's another critical point up here. You can see it won't be a liquid or a gas right here if the pressure is so high past a certain temperature. It can't be a liquid, but it can't be a gas either at that temperature. I think this may be plasma or something up there. I'm not completely sure. Anyway, that's more about what triple point is when you get to that question. Yep, no check-in, no closing, just a review, so you have time to do the whole review. And when the answers post. Please consider those. It'll help you check your answers, and if you get stuck, it's a good resource.